Hey, everybody. Yeah, and as others have observed, there's nobody here but me. You're a big black blank. It's all very brightly lit up here. But thank you all for being here, and thank everybody for being online that's joining us. This is going to be fun. This, to me, is extremely exciting because I've been talking about and trying to figure out ways to reuse business logic in some pretty innovative, well, maybe they used to be innovative ways, and there's been kind of this pause while we went off and dabbled with front ends that were built with JavaScript instead of .NET, and now we're back to where we can build front ends with .NET. So I'm very, very excited about technologies like Uno and WebAssembly that really bring us back to a place that I enjoyed a great deal through much of my career. And I'll get to that in just a moment. CSLA, for those that don't know, is a framework that really helps provide a home for business logic. And the whole idea, at least in my mind, is that we've got all these great UI frameworks, right? Like XAML-based or HTML-based now, or Windows Forms, all sorts of things that help us be very productive creating user experiences. And we've got all of these great frameworks, in fact, arguably way too many for talking to databases, right? ADO and DAO and RDO and ODBC and OLADB and all the things we've had over the years to talk to databases. And a lot of energy goes into the UI and into the databases. But I've always felt, because I come from an enterprise development background, and that's kind of what I've done for a living throughout my entire career, I've always felt that business logic was also important, right? Just because the user's got a shiny, beautiful user experience, and just because we've got lots of data, something has to marry those two together in a meaningful way. And why is it that there are no frameworks, no real support, no formalization of concepts around business logic? Right. This, in a nutshell, is where CSLA comes from. And so the idea is that you take a layered architecture, such as the one on the screen here, and you say, okay, we've got some sort of an interface layer, whether that's XAML or Windows Forms or HTML. Behind that, we've got some sort of control layer, whether that's a controller or a presenter or a view model. Right? Those top two layers really comprise what traditionally people talk about as the presentation layer. Right? The presentation layer, at least in the modern world, you almost have to divide it into those two parts because we have become very good at separating the code from the markup, right? Which is, to our credit as an industry. Behind that yet, you would hope you've got some sort of business logic, and that in and of itself would be a separate layer. Now the reality is that doesn't happen very often. The reality is that usually we write the business logic in code behind, button clicks or lost focus events, or if you do use controllers, the business logic often ends up in the controller, which is exactly, that violates the pattern. Or business logic ends up in a view model, which also violates that pattern. But the problem is that if you don't have a defined home for business logic, you got to put it somewhere, right? And probably very few of us want to put it in the database anymore. I mean, that used to be such a big deal, right? Everybody's like, well, I'll just write all my business logic in SQL. Right? But that turns out to be the least scalable, most expensive place to put anything is in the database, right? So I think we generally have learned this over the years, that we don't want to put it there, which really leaves you with an M, a V, or a C. And you don't want to put it in the view, you don't want to put it in the model, which is actually where it should go in my mind. I'll come back to that. So we end up putting it in the controller or the presenter or the view model. What CSLA is all about is saying, why is it that the model has to be an anemic container for just dumb data, right? Well, so goes the thought, well, if I go to I call a service and I get back data, it comes back in a dumb set of objects, right? Just, classes that have no behavior other than to contain data. If I call entity framework, I get back an entity object. The entity object has no behavior other than it contains shaped data from the database. And so I'll get to the time frames here. For a very long time, I've been suggesting that in fact, you should take the stuff out of the database or out of the service and map it into a set of business domain objects. Actually use domain-driven design, create a set of objects that represent your problem space. Those objects encapsulate not only the data, but also all of your business rules. And then were you to have a framework that helped you do that by having a consistent rules engine and support for things like data binding and mitigations for differences in platforms like Windows Forms, WPF, and UWP, for example, all have subtle idiosyncrasies about data binding. And so suppose that you had a framework that helped you mitigate those differences so you, as a developer, didn't have to worry about them, right? This is, in a nutshell, what CSLA is trying to do, is help you create the green box that contains your business logic, right? And then behind that yet is where you have things like Entity Framework or Dapper or ADO.NET or whatever it is you're using to talk to your database. And then the database itself becomes the final layer. Now, if you take this layered architecture and extend it into a lot of business scenarios, you say, well, in reality, those layers are not all running on one device, right? We actually put networks in between some of these, and this diagram is a pretty common picture, and I think especially in today's world, when you start talking about WebAssembly and Uno, this becomes a very compelling picture, because on the client device, whether it's a phone or a tablet or a PC or a Mac or what have you, running in the browser, I've got the interface, and I've got the interface control, view models or whatever I'm using. I would really like to have some chunk of my business logic running in the browser or on the client device. The reason being that I want to give the user an interactive experience. So for better or worse, I've been around in the industry long enough. I got my start back when we were still using VT52 terminals, and all of the code ran on a mainframe or a mini computer, what we nowadays call a web server, but right? And it projected all the stuff out to a terminal, which is what we now call a browser. And you would, the user would fill out a form, and then they hit the transmit key, which we often call a save button or a submit button. Right? But realistically, the web just recreated the mainframe. But there was a brief shining period of time there in the 1990s when we were able to create smart client apps that also had smart servers, using C++ or Power Builder or Visual Basic. In my case, it was a lot of Visual Basic. And we used this architecture, right? Sitting on top of, at the time, Microsoft Transaction Server and Com+. And so what I'm trying to get at is that what I'm describing here is not in any way new. Right? This is all ideas that really crystallized from 1996 through 2002 or so. But then we lost it all for the last decade because we all went to the web and quit writing. Basically the web was using one entire set of technologies that was completely and fundamentally different from anything we ran on the server. So the idea of sharing code between the two or sharing anything pretty much went out the window. And if you wanted to give the user a rich experience, an interactive experience, you had to write much or all of your business logic in JavaScript or some variant, right? But then you don't trust the client because the client can be hacked very easily. So you also have to rewrite all of that business logic in C# or VB or Java or whatever it is that's running in your application server, because you have to rerun it assuming that the browser was hacked. Right? Is this not true? And so here we come back with with WebAssembly and whatnot, where we can run C# code in the browser again, or on the client again, I should say. Much like we could back in the Windows Forms, WPF, VB days, right? Days long gone by. But now we've got this opportunity to create one DLL, for example, using maybe net standard that deploys into the browser or onto the client and runs business logic. And we still probably don't trust the client. I mean, let's be real, right? But we can deploy that same DLL to the server. So we can run it on the server in a trusted environment to kind of double check, but we can run it on the client in order to give the user a rich experience. Right? Really the best of both worlds. This is, in a nutshell, the long-term goal of CSLA is to do exactly that. And now with things like Uno or Blazor, it's like, oh, baby, right? Everybody is adopting this same exact type of model. So I get kind of excited. I think it's really cool. So, you know, and the other thing that's going on in today's world that really is not the focus of this conference, but is still a major trend is container-based servers, running things cloud native. And so you say, hey, I've got this front end, whatever it is, whether it's, you know, Android or web or whatever, and the front end apps are all talking to a cluster of containers, probably running in Kubernetes, right? So really what I want is to be able to take my code that's running on the server, put it into a container, and then have it auto-load and do all the other cool stuff, you know, automatic updates and you know, scaling and so forth that you get with Kubernetes. And so, which we also get today. This is the really exciting part, right? Because we're saying .NET Core on the server runs on Linux, runs on Windows, runs in containers. If I write all of my code using .NET Standard DLLs, then my code can be run in these containers, and I get all of this great server-side capability, in addition to being able to run all sorts of places on the client. So it's just, to me, this is super exciting. The future looks bright, brighter than it has in many years, especially if you're a .NET developer. Now you still might, and in fact in a lot of cases, many of us will create what you might call an edge app. So an app that's maybe running on my phone, and it doesn't, you know, really it's not any sort of N-tier model, it's just calling services that are remote somewhere over the internet. Very common. But I put this up here because I want to reinforce that this architectural concept remains intact. You always have some sort of interface layer, interface control. You always need some sort of business logic, etc. Interestingly enough, the same is true when you're trying to create a service, because services are standalone autonomous applications. It's just with a service, the interface, instead of being HTML or XAML, the interface is probably JSON. Right? But everything else is consistent and the same. You still need interface control, you still need business logic, you still need data access. Right? It's a consistent repeating pattern in our modern industry. And I'm flying through the slides because I'm trying to get to the demo part, right? This is the cool bits. So just kind of, again, to reiterate what CSLA is all about is really it's a framework that you grab a NuGet package and start using CSLA that allows you to do the things I've been describing in terms of creating that green box so that you're able to create, using a consistent set of patterns and implementation flow, create your business logic. And then once you've created that business logic, especially today, where you can create it with a .NET Standard DLL, then you can run it on Windows, you can run it on Linux, you can run it in containers, you can run it on Android, iOS, and now in the browser. It's just a matter of where do you choose to deploy it. CSLA is an open source framework. It's been, well, it actually, and I think my next slide gets to this, this goes way back into the 90s when open source was not really yet a mainstream term. So when I first released this, it was freeware. I guess I'm not as hardcore into the open source free software stuff as Miguel, as he talked about it this morning. But I do want to pause at this point. And the reason that I've made this thing freeware and then open source over the years is because I built my career on top of open source. or well, again, at the time it was called freeware and shareware. But yeah, I got my start in the industry on the DEC VAX platform, and we used to get magnetic tapes twice a year, like literally, the big magnetic tapes, full of freeware and shareware. And then we started to get the GNU Foundation stuff that was, copyleft and, all of that. But without those tools, I would have never, I think, been able to build my career up to what it was at the time. And so when I had an opportunity to contribute back into the world, to me, it was a no-brainer, right? And for what it's worth. So yeah, I've been doing this. CSLA is now 22 years old as of like this month, which is kind of cool. It started as a COM project and then became a .NET project. So I've been running an open source project for an extremely long time, which again, I think is kind of cool and fun. And over the years, of course, what's really cool is that it started out, especially the .NET version, was like, oh, we do Windows Forms and web forms at the time, and then WPF, and then Silverlight, and ASP MVC, and and now WebAssembly. But the number of targets for .NET has truly grown over the years, and especially again in the last just very few years, it's been just amazingly fun to be a .NET developer. I don't think I'm going to walk through the detail of this slide too much, other than to say that CSLA's kind of meta goals, again, my background is an enterprise developer. And as an enterprise developer, generally speaking, I end up building software, and I'm sure many of you do too. You build software that you expect is going to run for somewhere between 10 and 20 years, sometimes longer. And so your software has to be maintainable, it has to be consistent, because it's not just maintainable by you, because you probably won't stay forever, right? It has to be maintainable in a way that you can hand it off to other people easily and they can maintain it over time. Also, it has to be maintainable in the sense that over a 10 to 20 year period, the user interface technologies, for a fact are going to change. There's never been a 10-year period in my career where the user interface stayed consistent. Maybe Windows, but even that's debatable because the web showed up in the middle of that and really transformed the way a lot of us think about it. And I don't know what the next UI, thing is going to be, whether it's virtual or voice or whatever it is. But GUI-based interfaces won't last forever. And even if you stay inside the GUI-based world, right? We went from Windows to web to Mac to, it's still not consistent. So the point being that everybody focuses on, man, the database is this magical thing that's like the absolute most important thing in an enterprise is the database, which I can't necessarily argue with. But a database without business logic is essentially useless. And so I would argue that, yeah, the database is going to evolve very, very slowly. It's the jewel of your company, et cetera. The business logic is going to evolve almost as slowly, and the UI changes every few years, right? And so this idea of having, a really consistent way of dealing with data is awesome. I think it's important to have a really consistent way of dealing with business logic as well. CSLA is often confused because I start talking about objects and domain objects, and people are like, oh, it's just another ORM. But it's not at all an ORM. ORMs in no way, none of them, deal with business logic. That's not their purpose, right? Their purpose is to abstract how I deal with databases. CSLA actually sits on top of an ORM, whatever one you want to use, and provides a place for business logic, and it doesn't really care how you talk to the database. It cares that you do talk to databases, but it doesn't care how, right? It's actually, and nor the same with the UI. It's not a UI framework. So sometimes people have looked at, especially when MVVM started to become a big design pattern, back when WPF showed up, people were like, oh man, CSLA, I can use that to create my view models. Which, the thing is that if you're following domain-driven design principles to start with, really the MVVM design pattern becomes only marginally useful. Because MVVM, for those that haven't really followed this, right, but even if you have, really there's two big reasons for using a view model. One is your model is in the wrong shape. And so you need to create new properties to support the UI because your model was in the wrong shape. Probably because you just did a database query, right? Well, CSLA gets rid of that complete need entirely because you should have created your domain models, your domain classes, based on domain-driven design, and so they should already be in the right shape. Right? So whoop, that half the reason for MVVM went away. The other reason, and this is particularly true for XAML, is that because you can have binding from events in the UI to your view model can implement all of your verbs, like navigation type stuff and that, everything that a UI might trigger should end up being an action that is implemented in your view model. Now that part remains very, very valid, right? So I do tend to use a view model approach with CSLA. It's just my view models have exactly one property, which is called model, right? Because my model's already in the right shape, so I just need to expose it to the UI so it can be data bound. And then I have verbs implemented in the view model to do things like go to the next page, go to the last page, refresh, or whatever it might be. So let us go do some demo-y things, shall we? So I thought I would start just by kind of reinforcing why it is that I think this new world we're entering into is so compelling. And that is that here's an ASP MVC project, and fairly simple. It uses CSLA behind the scenes, but of course all of the code is running on the server, right? But in almost all these pages, if you've done any MVC, you're going to go, oh yeah, those were created by a wizard, which they were. I am not a UI person. That's Billy's job. He'll be up next. But if I say I'd like to edit this person, here's some interesting things going on here. First off, it says person name required. Now that did not come from the UI. This is the kind of the point of starting to try and tease this apart. Anything like that, like a tooltip or informational message, really should come from the business layer, because this was a business layer thing. I want it to show up in any UI. And so I really don't want any particular UI to implement this sort of a thing. So really that text message is being displayed by MVC, but it came from my business layer. Now what gets even more fun is that I have some other rules that are here. One of which is that for whatever reason, my names can't have Z in them. Some user has a phobia about Zs. And also, we think the first letter of names should probably be capitalized. So now I've put essentially an invalid value in here, but as a user, do I know this? And the answer is no. Well, that's really too bad. Now, if I click the Save button, I get to find out what was wrong, of course. And the reason being that I took this form, I posted it back, right, just like the old transmit key on a mainframe, right? We sent it to the mainframe did some work, and then sent back a laundry list of problems, which are now being displayed. Now, the upside here is that I'm maintaining 100% separation of concerns, in that the no letter Z allowed text and the check capitalization text and the person name required text, all of those are coming from my business layer. In fact, they're coming out of the CSLA rules engine, and that rules engine, as you might infer, has the concept of informational messages, warning messages, and error messages, in addition to being able to calculate values and all the other things you would hope a rules engine could do, right? And the MVC page, my razor view here, is rendering this data back to the user, but it actually is just rendering. It's just got a control that says, hey, render whatever error messages came from the business layer, whatever warning messages came from the business layer, just render them. So there are 0 rules in the UI. So let's step forward just kind of to an intermediate step, and delicate, right? Because like Blazor is arguably a competitor for Uno, but still, I just want to step forward through time, and say, okay, well here's a Blazor example, same exact business layer, right? As you would hope, right? This is the whole idea, but now things get way more interesting because if I list my people and I say that I would like to edit this person, and now if I go and type Andy, let me zoom in so you can see what's going on, whoops. And then put a Z here. But notice how I'm getting this stuff in real time, right? Again, my UI might look better if it was done by somebody who knew what they were doing. But notice, I mean, instant, right? Now, this is what users want. This is why users are like, yeah, all that web stuff was cute, but can't you write it, to be more like a real app? And of course, that's what has driven the web world to do Angular and React and whatever other frameworks, is because the idea is ultimately that the end users want a quote-unquote real app like they used to have with Windows. Except, again, remember, everything I'm showing here, all this text that's displaying, is coming from a business layer. It's just in this case, I was able to deploy the business layer to the client. That CSLA DLL was compiled, running in WASM. It's running on the client, and it's using a type of data binding that Blazor has in order to do all of this immediacy. Now, I don't trust the client, so ultimately, at some point when and if I click the save button, the server also has that DLL and gets to run the code again, right? But at least I don't have to write and maintain the code twice as a developer. I write it one time, and I just kind of let CSLA make sure the rules run on the client and the server both. So now let's look at an Uno example. So this one's written with XAML, but and again, my UI every time is a little bit different because the technologies are a little different in my understanding and capabilities of creating a real UI. But notice the same exact, as you would hope, it's the same exact behaviors because it's the same exact business logic. Right? Running on the client, running on the server, running across 3 different platforms. And if I wanted to take the time, the same logic can run on Windows Forms and WPF and console apps and blah, 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 right? So how does this work? If we actually look at the Uno sample, and this is a sample out of everything I'm showing you here, in fact, you can get to from CSLAnet.com, right? It's all hosted on GitHub. All these samples are out there. And really, a lot of what I'm showing you, especially around the Uno and Blazor stuff, all deals with CSLA version 5, which will come out next week as soon as I can reconcile Microsoft's final version numbers when they release .NET Core 3. So the key here, because this is generally using Uno's templates or project template, same as you've seen this morning, because I used their template, I've got a Droid head and an iOS head and a Windows head and a WASM head, right? Four different interfaces. And then I've got the shared project that contains whatever shared UI code there is. I've also, though in this case, I've got a business library project, which is my reusable business logic, and I've got a data access project because, again, if we go back to the layered model, I would hope that I've got my presentation stuff and my business logic is separate and my data access is separate yet, right? And especially when we start looking in something like a WebAssembly model, I probably don't want to deploy my data access to the client. I mean, I might, right? It's all architectural. If you might say, well, wait, didn't this morning I heard that I could run SQLite in the browser, and so if you're going to follow that model, you really might want the data access layer, of course, deployed to the client. We can do that, right? But if I'm creating an enterprise app that has some sort of governmental regulations around data privacy and so forth, the reality is that the client can run some logic, but at the end of the day, like at least in the US, there's different regulations on different industries that say that the client can't ever directly talk to a database, because for that to happen, the client would have had to have the database connection string, and that violates privacy laws, right? So the client has to talk to an app server. The app server, in a secure environment, somehow talks to the database, and that way we protect the connection strings and so forth from any sort of client, right? And so in this case, what I'm suggesting is that, yes, I'm going to deploy the business library to the client because it has some good client-side business logic. I'm going to deploy the business library to the server because I don't trust the client, so I want to rerun stuff. And then the data access layer is only going to be deployed to the server because that's the only place that I should be talking to the database. So I've got some good separation. The rest of the projects in here are actually parts of the CSLA framework that are only in here because literally I'm in the middle of debugging and making sure this stuff all works leading up to next week's release. Normally these would all be NuGet references, but we're looking at like live on the edge code, right? Oh, and then the final thing that I should point out is that in fact there is obviously an app server project, which is nothing more than in fact it has no actual code to speak of at all, other than it has what are called data portal controllers, these are the endpoints for the client to talk to. And so, but there's no behavior in the app server other than being a host for endpoints. And the app server, in this case, is written as a .NET Core website, so it can be very easily run inside of containers, inside of Kubernetes or something like that. So all the modern happiness. So where CSLA really comes into play is in that it gives me a way to create my domain classes, and in this case, it's extremely simple scenario, but also my rules. And so, for example, there's this rule that I've got that says that that there should be no Z's in my text, and so I actually inherit from something called business rule, require a property to attach to, and then get that property value, make sure find out if it has a Z in it or not. And then if it does, I'm going to add an error result. Or I could add a warning result or an info result. But also, inside of this execute method, I could do arbitrary things like recalculate. For example, I could have a rule that's triggered when quantity or price changes, and then it recalculates the total amount on the line order, possibly also including discounts and blah, 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 right? To give and I only have, of course, so much time to talk about everything with you today, but to give you a sense of how complex the rules engine can get, a gentleman, I kind of wrote the base of this thing, and it's kind of inspired by a book called Object Thinking by David West, written now quite a few years ago. About this idea of having every rule be a class, and that way you can test the rules using basic unit testing and good practices. And so I incorporated this into CSLA, and then a gentleman named Johnny Beckham from Norway started using this while he was working at a bank, a relatively large bank, and their whole thing is based on CSLA, and so he's like, well, it needs to do this, and it needs to do that. And this is the advantage of open source, is it not? Right? He's like, this seems like a really good base, but I want it to do this more, more sophisticated stuff. And so we worked together, and he by far did most of the work to build out this business rules engine so that it can run of an extremely large, complex banking scenario. So, you know, it's kind of cool, right? That's all I'm saying. This is why open source is so neat. So where is this used? These rules end up being used inside of domain classes. And again, and in a sense, this is not a great example because this really is just some simple forms over data. So this example, you could walk away from this going, it's just another way to create a data, you know, simple CRUD data entry form. But if you really buy into domain-driven design, what I've found in my career is that probably if you've got 100 different types of data, you'll end up with a whole lot of screens that really are largely screens over data, right? Just simple forms over data. And a lot of those end up being the kind of things that are used once every year, once every quarter, you know, infrequently by end users to kind of maintain and keep things running. And then there's a small set of screens, sometimes only 1 or 2, sometimes like 5, that are the screens that some people in your org spend 8 hours a day, every day, in these very complex screens, right? Whether it's an order entry screen, or it's the screen for a call center, or it's the screen where they're doing insurance quotes, or whatever it is, right? And those screens, oh my God, they are not just forms over data. Or maybe they are. They're forms over all the data, right? And that's where you really need to remember that domain-driven design is not look at a table, create a class that looks like the table, right? This is where I'm truly creating a set of domain classes that represent the business problem of that screen that people are sitting, like living out their lives on this screen, right? And they're going to interact with lots of other tables or services and so forth. Unfortunately, this is not that complex of a demo, but I always like to reinforce that because I think that's really where things, especially CSLA, sings, is in a case where you're really building an honest-to-God enterprise app that has some interesting screens. In this particular case, though, you know, just to keep things simple, this is a person edit class. It says, hey, my job is to help you edit a person. I'm going to inherit from something called business base because that's where I get the rules engine, right? And then I'm going to start declaring my properties. And some interesting things here that I think are worth noting is that every property looks exactly the same. Again, we come back to this idea of maintainability, not just for me, but for everybody that's going to be, you know, keeping this application running over the next 10, 15, 20 years. If every property and every class always looks the same, right? Very easy to understand, very easy to train, very easy to do things like create snippets and say, hey, I would like to add a new property. Right there, now I'm done. I created a property. Right? Again, because everything has this level of high consistency, it means as a developer, I can be highly productive. Even a junior developer starts out being really quite productive because everything is so consistent. Now, a lot of folks also, and I do too, really like data annotations attributes. Right? These got introduced way back when when Microsoft first started doing WCF services, I think in like 96, 97. The thing about data annotations attributes is that they're really nice because they're readable, right? Look at that, that's a required property, woo! Right? The drawback is that as soon as you're in a multi-tenant scenario, right, if this code's running on the server, and some of my tenants have this as a required field, and some of them do not, now data annotations kind of start to fall apart, right? Because they can't be there or not there, they get compiled in. There's some other things that are traditional drawbacks, and that is that data annotation attributes are actually enforced by UI frameworks. In other words, Microsoft built ASP-MVC to see those attributes and enforce the rules in the UI. They did the same with Silverlight. Silverlight used to understand these attributes, right? But Windows Forms didn't, because This came after Windows Forms. This came after WPF. I don't think UWP automatically understands them, right? For example, but CSLA actually does. I think they're awesome, right? For a lot of simpler, smaller apps that are not multi-tenant, I mean, the readability is huge. So CSLA actually picks up all the data annotation attributes and makes sure that they get run even on older platforms like Windows Forms or newer platforms like UWP or Uno, where these are not automatically triggered. Right? So basically, it becomes a universal rule that's enforced in the business layer, not the UI layer. Because rules should never be enforced in the UI layer. At least this is my view. The great thing is that because we can create our own rules inside of CSLA using its rules engine, it becomes very realistic then to say, well, what I'd really like to do is add more sophisticated rules, not just those simplistic, there's only 4 or 5 attributes, right? But I want other rules. For example, in this case, I'm saying I've got some info text that I want to display on this property saying that it's required, because I want to give the user that little extra, nod. There's a warning that I want to make sure the first letter of the name probably should be uppercase, but that's not a rule. You see what I'm saying? In other words, maybe it's supposed to be lowercase. People have names that are very unusual. It's just probably it should be uppercase. Whereas for whatever cockamamie reason, my business sponsor told me that there could be no Z's in somebody's name. And so we've got that rule here. Now, if we look at the Uno shared project here, right, because that's where all of the UI actually is, and open the edit person XAML page, and maybe switch us off Android over to UWP. There we go, that looks a little more tidy. So this is my data entry page here. And so here we can see that I've got a text box. It's binding to the name property because I've got a view model underneath here that's exposing my business object for use. It's a two-way binding, and I want in my case, I want the update source trigger to be keystroke by keystroke, just because that makes for an awesome demo. Right? If you want, you can do it where you tab off the form, or but honestly, I should say that again. Yes, it makes for an awesome demo, but in real life, I often personally choose to do keystroke by keystroke validation because it's running on the client, right? There's no problem just running this logic, and it gives the user this really great experience. Then I use a helper class from CSLA called a property info because it turns out that what CSLA does on a per property basis is it tracks a whole bunch of meta state for you. Again, because it's got this rules engine and kind of rich set of behaviors. So CSLA at all times for every property knows, is the property valid or invalid? Does it have any warning messages? Does it have any info messages? Is it currently running an asynchronous business rule? So you, for example, could have a business rule, so as I'm typing, it's sending a query off to the server to see if that field already exists in the database or something like that. So that could be an asynchronous business rule. And the reason that I want to expose all of this meta state to the UI is because then I'm allowed to do element binding and say, well, here I would like to expose whether it's valid and what information text, warning text, error text. If I wanted to, I could have a busy animation so that, excuse me, if in fact name info is busy because it's running an async rule, maybe I put a little spinny thing next to the text box for the user. Right? That type of thing. But the beauty of it, especially with XAML, I love XAML so much, is that you've got this really sophisticated and powerful binding, which means that I don't need to write any code to do any of this stuff, right? Not code in the UI, right? I wrote all the code in the business layer so that it's reusable across platforms, and then I rely on XAML binding to do all of this complex stuff, so I don't have to write code. Again, this really, really helps in my mind with the clean separation of business logic versus all of the presentation of whatever I want to show the user. Now, selfishly to me, this is actually super important because I'm really bad at the presentation part, right? So if I create this really rich business layer, then ideally, I can have Billy Hollis come along and create a beautiful UI, and we all win. I'm just plugging Billy's talk. That's all I'm doing. All right. So there are some other interesting things, though, that I want to call out just in the last couple minutes that I've got, and that is, in today's kind of modern .NET world, you end up with some interesting things. For example, especially as we look into .NET Core 3 and moving forward, the idea of using dependency injection and the whole built-in configuration subsystem that's part of .NET Core, especially because, so I'm not only super bullish about the whole WebAssembly, Uno, Blazor type thing, I'm also extremely bullish on the whole container Kubernetes thing. And that means that I'm extremely bullish on something called 12-factor. So if you go to 12factor.net, like 12factor.net, there's basically, they've taken the time to document 12 design patterns that you should follow for creating high-quality cloud-native applications. And .NET Core has embraced those and enables them in some pretty nice ways. And so probably not surprisingly, CSLA, especially on .NET now, .NET Core follows suit and says, here's a configuration scheme that I'm using in order to configure some things like CSLA's endpoints and whatnot. Just at the moment, especially when we start looking at UWP apps and WebAssembly apps, we're still in kind of a not perfect spot in a lot of ways, because those environments have yet to fully embrace being this whole cloud native idea. But if we start looking at, for example, at the MVC app, and this is kind of where I think things are going, which is why I'm calling this out, because I think ultimately even the client-side code is going to end up doing this sort of thing. But here, you end up doing things like calling add CSLA, and it's going to load the configuration for the server, and using this new configuration subsystem that's built into .NET Core. And the configuration subsystem by default says, hey, did you give me a command line parameter? Did you give me values from the environment? And then as a fallback, because ideally in a cloud native environment or scenario, you get config from your environment, right, from the container you're running in. And then as a fallback, yeah, okay, I'll look at old-fashioned config files. But really, the idea of using an app config or a web config should go out of all of our vocabulary, right? And this is a case where, again, it's primarily server-side stuff, but I've started personally dabbling, and I'm sure I'm not alone, in trying to figure out how to take the .NET Core config subsystem and extend it to client-side scenarios in ways that hopefully do the same level of abstraction, right? Ideally, I would like to see every project that exists out there end up with something equivalent to the startup class that we have in ASP MVC. Right? That's where you configure your stuff. I think that would be pretty ideal. But even in the case, and this I think is quite exciting, even in the case of client-side code, you can still, sorry, where's my cursor? There we go. You can still do things like this, where you can create a service collection. This is the dependency injection model that's built into .NET. And then you can add things to it. For example, I'm saying, okay, I would like you to add the CSLA services to it. And then I also, if I'm running my data access layer on the client device, maybe I want to add my data access layer into the dependency injection list. And that way, all of my dependency, or I can rely on the underlying dependency injection model. So if we go back, this will be my last little guy here. if we go back into my domain object, I say, hey, I need to fetch the object, and clearly I need to fetch the data ultimately from some database or something, but I don't want to care, right? Again, separation of concerns. I'm the business layer. Somewhere over here, there's a data access layer. I would like you to just inject into me a data access layer, and I'll just talk to it. And maybe it's a mock database, maybe it's a SQL Server database, maybe it's an Excel spreadsheet. Psh, doesn't matter to me, right? All I know is that I got access to an iPerson DAL that I can talk to, and that was injected, and it was set up originally by the application config. Right? And so where I'm going with this, and this is all running in Uno on the client in the browser, right? I mean, we're talking full-blown modern dependency injection, all the abstractions and all the separation of concerns. Everything that we've learned on the server now extended back into the new smart client. So to me, this is just super, super, super exciting. And with that, I think maybe I've got like 2 minutes for questions or whatever, but otherwise, hopefully you're as enthused as I am, because I'm very enthused.